Welcome to the lesson on relating geometric sequences to exponential functions. So, first we need to know what a geometric sequence is. A geometric sequence is the ratio of any term to the previous term, and that is called a constant. Okay, this constant ratio is called the common ratio and is usually shown as R. The geometric sequence for a first term is usually called A1, just because it's the first term. And usually you will see it, and it looks really complicated right here, but I promise it's not that complicated. It shows like A1 times R, A1 times R squared, and so on and so forth. Basically what this means is if we had a first term of 5, each time we moved up in this pattern, you would go multiply by 2 each time we go up. So 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40. This is very different from the previous sequences that we have been dealing with or that you have seen before, the arithmetic ones, where it would be like 1, 4, 7, where you're just adding 3 each time, okay? So then you would know that the next one would have to be 10, so on and so forth. Instead of adding, we are now multiplying, okay? And you will see this usually if we were to go backwards. Let's say I start with a really big number, like, okay, and I'm gonna say big as, 240. And then my next term is 120. And then my next term is 60. Okay, and then my next term is 30. Okay, if you notice, each time we are going down in this particular sequence, 240 to 120, we are dividing by 2. But in geometric sequences, we're not going to be showing it as a division. We're going to be showing it as multiplying basically a fraction. So instead of dividing by 2, I could also multiply by 1/2. Okay? So if you think about it this way, 120 times 1/2 is basically the same as 120 divided by 2, which would then be 60. All right? So that's what a geometric sequence is. So let's look at an example. So in this case, it asks you, tell whether the sequence is arithmetic or geometric. Then write the next term of the sequence. All right, so we are going to look at sequence A first, this 3, 6, 9, 12, 15. All right, so the first term in this sequence is 3. Okay, we want to know what the ratio of the consecutive terms are. Basically, we want to know whether or not they're being added or multiplied. Okay, so we can do this a couple different ways. We can divide 6 divided by 3 and 9 divided by 6 and 12 divided by 9 and see if it is consistent as we go through. So I'll show you an example of that. So if we were to do 6 divided by 3, it would be 2. Our hope would be that if we divided 9 divided by 6, it would also equal 2. In this case, it does not. It equals 1 1/2. And if I were to do it again, 12 divided by 9, it would be 1 1/3. So we know that this is not a geometric sequence automatically because the ratios, or if you were to divide each number, they are not consistent. Okay, so this is considered an arithmetic sequence. Okay, so I'll put an A next to this one so you remember. Okay, for B, we're starting with 128. We're going to 64, 32, 16, 8. I'm going to do the exact same thing as I did up here. I'm going to divide. So I'm going to do 64 divided by 128. I'm going to do 32 divided by 64. I'm going to do 16 divided by 32 and 8 divided by 16. All right. So, Here it is. 64 divided by 128 is 1 over 2. 32 divided by 64 is 1 half. 16 divided by 32 is 1 half, and 8 divided by 16 is also 1 half. So since all of these have 1 half in common, this means that this is a geometric sequence. All right, and then I'm going to find the next term of the sequence. So if I were to continue with this, I know that each time I'm going to be multiplying by 1 half or dividing by 2. So I'm going to say that 8 divided by 2 for my next term is, or 8 times 1 half is going to be 4. So that's how we would get our next term. All right. All right, so now here's how we're going to relate our geometric sequences to exponential functions. So we've been dealing with a lot of graphs where we have a graph that's going either up, which we have exponential growth, or we have one where they're going down, which is exponential decay. Now we're just going to take our terms and we're going to turn them into we're going to take our geometric sequences and we're going to turn them into these types of graphs that we've been talking about. So I am just going to write, if you remember, we're going to talk about this pattern right here, this 128, 64, 32, 16, 8. Okay, and those are going to be our terms, our y. Okay, so I'm going to write it this way. So my x's, the position, meaning that the first term, the second term, the third term, the fourth term, and the fifth term. I know that my first term is 128. It gives me that my second term is 64, third is 32, fourth is 16, and my fifth is 8. If I wanted to add on a sixth term, which is the one we found, I could also say that that one is 4, so just to extend my box a little bit. Okay, and I would literally just graph these points. So each coordinate point, for example, this is 128. Okay, 264, and you get the drift. So if I go through and I were to graph each of these, my graph would look like this. So I have 1, 128, 2, 64, 3, 32, 4, 16, 5, 8, and then if I were to graph that sixth point, it would be really close to the line because the way that they have the graph made it would look like that. And I would just complete my graph by drawing my function right through. And if you notice, it looks just like the functions that we have been graphing the last couple days. Okay, so that's how you would graph a geometric sequence. If you notice, the geometric sequence is not linear. It normally is not. Okay, that's more of the arithmetic ones. All right, so there's this fancy schnazzy little formula that goes along with it, and it looks complicated. I promise it's not as complicated as it looks, okay? The one that I am referring to is this AN equals A1 times R to the N minus 1, okay? Do not freak out. All this means is that A1 is my first term, that R is my ratio. So let's say whatever it's being multiplied by. So if it's going up by 2, it would be 2. If it's going up by 1 half, like the function we've been working with, it would be 1 half, okay? And then this n is just the number of the term that you're dealing with. So that means that, for example, if I look at this graph that I have at the top, if I have my first term is 1, 2, 3, 4, Each time this goes up 1, then this goes up by multiplying 1, okay? And I'm going to show you an example of that right now, okay? So it says write a rule for the nth term of the geometric sequence in example 1. If you remember in example 1, my first term was 128, and my next term was 64, and then I had 32, and so on and so forth. And they want us to find A10. When they're talking about A10, that means they want the 10th term, okay? So I'm just going to plug in the information into my formula. So right away, I'm going to use my formula right here. My first term is 128. My R, or my ratio, is 1/2 because I am multiplying by 1/2, and I'm just going to plug this into the information. So into the formula, I'm going to go 128 times 1/2 to the n, which is 10, because that's what I'm trying to find, minus 1. So if I were to actually solve this on a calculator, I could think about it this way. 128 times 1/2, I'm going to make really bad parentheses here, and 10 minus 1 is to the 9th power. Okay, we have been working with these the last couple days, functions that look exactly like this. So you would do 1/2 to the 9th power, and then take that information, multiply it by 128, and you will get, you should get, if you were to try it, 1/4, which I would highly recommend you do. So you get 1/4 on the calculator, it'll come out as 0.25. Unless you have one of those fancy snazzy calculators that keeps everything in fractions. So it'll come out as 0.25, and that would be my 10th term in the sequence. So if I were to keep going, this formula is awesome because it prevents you from having to write out the entire sequence, like 10 numbers in this case. Sometimes it'll ask you for the 26th one, and you really don't want to have to write out 26 terms. So this formula is your best friend, okay? Remember, A1 is your first term. R is your ratio, however much you're multiplying by. N is the number of the term that you're trying to find. Okay? All right, that's all I have for you. Let me know if you have any questions.